Hi, Sydney. It's Miss Carol, and I was just wanting to help you with the 5.1.3 quiz. And so I should have different questions than you on this quiz. And so I'm going to kind of work through my version, and then you can go in and do your version. Let's get started on question number 1. It says, what is the solution to the system of equations that is graphed below? And so you should have learned in the 5.1 lessons here that a solution to a system of equations when you're given the graph is where the where the two lines intersect. So in this case, the solution is right here. And let's just be sure that we know what we're looking at. The graph of y equals negative 2x minus 3 is this line right here that leans to the left. And I know that because I have a negative slope. Negative 2 is my slope, and so it leans to the left. And I'm crossing the y-axis here at negative 3, which is my b value right there. Y equals 3x plus 2 is the line that leans to the right, and I know that because it's a positive 3 slope. Okay, so that means that for every point, I go up 3 and over 1, up 3 over 1. So, and then it's also crossing here at positive 2, which is my b value. Okay, so that's just how I know which graphs I'm looking at, but also now I know that this the solution where these two lines equal each other is where they intersect. And so I can see that that happens at x equal negative 1 and y equal negative 1. So my answer here is A. Both x and y equal negative 1. Okay, so I can go next. Oh, submit. And next. Okay, same deal here. My negative line leans to the left, positive line leans to the right. The solution is where they intersect. So I see that that's at x equal a positive 1 and y equal negative 2. Okay, this is a little different problem. Gina made a table of values to solve a system of equations. First, she found that the x value of the solution was between 0 and 1, and then she found that it was between 0.5 and 1. Next, she went ahead and made this table. Which ordered pair is the best approximation of the exact solution? Okay, so now instead of doing a graph, we're going to just do a set of ordered pairs. And these are the same x values. So what they're doing is they're taking this x value, like 0.5, and they're plugging it in to y equal 4x minus 1, and they get 1. And they're plugging it into y equal negative 3x plus 5, and they get a 3.5. So since we know the x values are the same, okay, what we need to find are the two y values that are as close as possible. Okay, so we know here that we've got this between 0.5 and 1. Okay, those are my x values. So if I go down here, let's see, at x equal, so I'm not very close on any of these. I'm getting closer. I'm getting closer. Okay, so these, what we're going to do is just subtract the second y value, and let me get my pen going here. So I'm going to subtract, we'll call this y2 and y1. I'm going to subtract y2 from y1 on each of these. Okay, so for the first one, my delta, the difference, is 2.5. 3.5 minus 1 is 2.5. For the second one, 3.2 minus 1.4 is 1.8. Okay. The third one is going to be 1.1. Okay. Fourth one is all the way down to 0.4, so we're getting close. The fifth one here is 0.3, okay, and that would might be a negative there. All right, and then I have a -1. So now we can see that the change, the closest they are together, happens at 0.9, okay? And it's probably, let's see, there's nothing more to go on here. Okay, so if I plug in 0.9, then the y value, okay, I have to choose between one of these two. Okay, 2.1 is less than either of those, okay? But 2.4 is between these two. So that is more likely my best solution. So this is, again, an approximation. And what I did here is I tried to find the difference that was the smallest between the two y values. Hopefully that makes sense. Okay. Antonio graphs these equations and finds that the lines intersect at a single point of -5 and 0.25. Which statement is true about the values of x equal -5 and y equals 0.25? Okay, so the first statement says they show that the equations represent the same line. No, that's not true. Let's just verify that. And what I'm going to do is I'm going to put these in y equal mx plus b form because that's always easier for me to see whether or not lines are the same. So I'm going to rearrange this so that I have y all by itself. So I'm going to say 4y equals 16 plus 3x. Okay, and then I'm going to say that that is 3x plus 16, just kind of switching the order there. Okay, and now I'm going to divide both sides by 4, and I end up with y equal 3/4 x plus 4. Okay, so that's the first line, and that's as simplified as it can get. So I'm going to do the same thing with the other line. I'm going to rearrange it to y equals mx plus b by first adding x to both sides. So I get -8y equals 3 plus x, which is x plus 3. And now I'm going to divide both sides by -8. So I get y equal a -x over 8 plus, excuse me, that's going to be minus 3/8. Okay, so we can see that these are not the same line. And if I put a -5 in for x, and I should get 0.25 for y for both of these, but that doesn't mean that they're the same line. In fact, one of these lines has a negative slope, okay, and it's going to be a very gentle negative slope. It's going to be something like this. And the other has a pretty steep positive slope that's going to be something like this. Okay, so they are not the same line. So A doesn't work. If this is a solution, -5 and 0.25, they have to satisfy both equations. So B can't work either. And for the same logic, D doesn't work, but C, they are the only values that make both equations true. That make both equations true. There's other values that will make the first equation true, and there's other values that will make the second equation true, but that is the only value that is a solution for both. Okay, so that's what they're saying there. All right. Okay, on a piece of paper, graph the system of equations and then determine which answer choice matches the graph you drew and identify the solution to the system. Okay, I have another thing that we can actually do here. We can I'm going to move this to a different screen. We can actually use a graphing calculator, and the one that I like is metacalculator.com. So what I do is I say y equals 2x minus 1. I really encourage you to use graphing calculators. And then y equals negative x plus 5. And then simply scroll down and graph. And I can see that it's crossing here at x equal 2 and y equal 3. So my first, it looks something like that. My first graph looks close. My second graph might even look close. What's the difference between? Look, we have to be careful. Our solution here is at 2 and 3. The first one says it's at 3 and 2, even though the graph shows 2 and 3. So this one says 2 and 3. That one says 1 and 3. And this one says 3 and 1, which doesn't really make sense either. So here we are. Our solution is at 2 and 3. So you have to pay attention to that. And that's the graph that matches. Okay. Graph the system of equations below. All right, we're going to do the same thing. I'm just going to go back to my equations, and I'm going to replace this with x minus 1 and 3x plus 1 and graph it. And, oh, it looks like I might have done something wrong here. What did I do? Equations. 3x minus 1, not negative 3x minus 1, or 3x plus 1. There we go. That looks much better. So I'm down here at x equal negative 1 and y equal negative 2. And fortunately, that is one of my answer choices. Okay. Same deal here. I am going to graph, oops, x plus 5 and negative 2x minus 1. Graph it, and I can see that my solution is negative 2 and positive 3. Again, that is one of my potential answers, fortunately. Okay. The owner of a bike shop sells unicycles and bicycles and keeps inventory by counting seats and wheels. One day she counts 21 seats and 30 wheels. The equation representing the total number of seats is u plus b equals 21, where u is the number of unicycles and b is the number of bicycles. Select the equation representing the number of wheels. Okay, well, a unicycle has 1 wheel and a bicycle has 2 wheels, and we said that there's 30 wheels, so that should be our answer. Okay, the two lines below are not parallel. How many solutions are there to this system of equations? Well, if they are lines and they are not the exact same line and they are not parallel, then there is only one solution to the system of equations. Okay, the two lines graphed below are parallel. How many solutions are there to the system of equations? If they are parallel and they are not the same line, there are absolutely 0 solutions because they will never intersect. So there is no point at which they are the same. Now, if they were the same line, there would be infinitely many. If you're dealing with lines, there is never a situation in which there are only 2 solutions. Your answer here would be 1, 0, or infinitely many. 1 is when they're not parallel and they intersect. Okay? Infinitely many is when they are exactly the same line, and 0 is when they're parallel. So hopefully that makes sense. All right, that's all I've got for you. Thanks for listening.